particle having charge 10 to the power minus 9 coulomb. So let's see, Q is given as 10 to the power minus 9 coulomb. Now it's moving in XY plane. So that means you can say if it is X axis, if it is Y axis, and if it is Z axis, then the charge is moving on XY plane. Now in the fields of 0.4 joule Newton per coulomb, that means the electric field is given here. Then we can write that E vector equals to 0.4 J cap Newton per coulomb and 4 into 10 to the power minus 3 K cap Tesla. That means the magnetic field is also given. B vector equals to 4 into 10 to the power minus 3 K cap into Tesla. Experiences a force. So the force is also given. F vector equals to 4 I cap plus 2 J cap into 10 to the power minus 10 Newton. That is the force is given. So the question is asking for the velocity of the particle at the instant is meter per second. So as we can see that a charge Q of magnitude 10 to the power minus coulomb is moving in XY plane, and the electric field and magnetic field is also given, and due to the presence of the electric and magnetic field, the force experienced by the charge is also given in a vector form. So if you want to write the Lorentz force, that you know that Lorentz force for the charge in presence of electric and both magnetic and electric field, we can write Q into E vector plus Q into V vector cross V vector, where V is the velocity of the charge in presence of the electric and magnetic field due to the experience of force of the fields. Now, as you can see, that V vector and B vector, they are in cross product. So let us assume, let V vector equals to Vx I cap plus Vy j cap, since it is given that the particle or the charge is moving on xy plane, then we don't need to take the z component of the velocity. Now if we want to write what will be the expression of v vector cross b vector, so that means we can write a simple cross product I cap j cap k cap, where v vector is vx vy 0 and b vector is given as 4 into 10 to the power minus 3 only in k cap direction. So we can put as 0 for the I and j cap components. So 4 into 10 to the power minus 3 Tesla. So therefore we can do the cross product and we can write that I cap. So cross multiplication Vy into, so 4 into Vy into 10 to the power minus 3. Next minus j cap into 4 into or 4Vx into 10 to the power minus 3, and for k cap, as we can see, it will be 0 because the 0 are given for the I cap and j cap of the direction of the magnetic field. We can write plus j cap into 0. Okay. So we have the v vector plus b vector. So if we simply put the expressions for the vector notation, then we can easily calculate the value of Vx plus Vy. We can write plus Q into V vector cross B vector. So let us put only the values, the vector forms that are given. So 4 into 10 to the power minus 10 I cap plus 2 into 10 to the power minus 10 j cap expression of force in vector form equals to q into q is also given as 10 to the power minus 9. So you can put the magnitude directly 0.4 into 10 to the power minus 9 q e vector is in j cap, you can put j cap plus q into v vector cross b vector. So as you can see, v vector 10 to the power minus 9 is given. So 10 to the power minus 9, and in this side also they are 10 to the power minus 3. So let's put and let's write the magnitude for Vy into 10 to the power minus 3 I cap minus 4Vx into 10 to the power minus 3. So the 10 to the power minus 9, the charge will be multiplied or so for the simplicity, what can we do? We can take the 10 to the power minus 9 from both sides, from RHS to LHS, and just divide it. Then I think it will be easy to write it. So if we divide 10 to the power minus 9 from the both sides, then we can write 4 into 10 to the power minus 1 into I cap plus 2 into 10 to the power minus 1 into j cap equals to 0.4 only j cap plus 4 dy into 10 to the power minus 3 I cap minus 4 dx into 10 to the power minus 3. Here by mistakenly I missed to write the j cap. It will be j cap. Now it's simple, just add the I cap and j cap from the both side, or you can write by comparing the I cap and j cap from the both side. Then what can we get? Let's see. So as you can see that 4 into 10 to the power minus 1 I cap in LHS, and in RHS there have only one I cap, that is 4 V1 into 10 to the minus 3. So you can easily write comparing by comparing the coefficient of I cap and j cap from both sides. We have what we have? We have 4 into 10 to the power minus 9, which is the component of I cap, will be equals to only 4 Vy into 10 to the power minus 3, and 2 into 10 to the power minus 1, which will be equals to the sum of 0.4, since there are two components j cap, minus 4 into Vy into 10 to the power minus 3. So if you want to solve, then we can write for 4 Vy, 4 cancel out, 10 to the power minus 3 will be going to that side, and then it will be 10 to the power 3. So in upside it will be 10 to the power 2. That means we can write Vy equals to 100. If we calculate this side, then we can write, say 10 to the power minus 1 means 0.2. So just 4, 0.4 will be going to LHS. So minus 0.2 minus minus a plus. So 2 will be cancelled out as a 2. Then if I put 10 to the minus 3 to LHS, then it will be 10 to the power 2 means 100, then 100 by 2. So it will be there will be Vx, there will be Vx. So Vx equals to 50. So as you can see, the component of the velocity along x-axis and y-axis that we get. So in this question, it is asking for the velocity value. So we can write the velocity value here as the answer, that is v vector equals to vx I cap, that means 50 I cap plus vy j cap, that means 100 j cap. So it will be the answer. So let's check the options. 50 I cap plus 100 j cap, 50 I cap plus 100 j cap. So 50 I cap plus 100 j cap is nothing but the answer of option number 1. Thank you.